Hey guys, welcome back to another video, and today we'll be discussing about quicksort algorithm. So I pulled up this page from Wikipedia. Quicksort is one of the oldest sorting algorithms, which was invented in 1959 by some Harvard guys, and they published it in 1961. So here you can see it's the worst case is big O of n square, and the best case is like this, and the average case and the base case are, so both are the same, but there are cases where it's big O of n. So let's just not talk about the algorithm first, but rather than go to the simulation, so it's better and easier for you guys to grasp the idea of what's going on. So let's try to take an array of some numbers, let's say. So we are asked to sort them using the quicksort algorithm, right? So what do we do here? So we are given this array, so we have to initially define these three variables. One is x, one is I, another one is j. So x and I would always be at the 0th position of the array, and j would always be I plus 1. So our task here is to compare both x and j. So if x is less than j, then we increase j by 1. So here 4 is less than 7, right? So we increase j by 1. So j is now 9. So moving on, so now we compare 4 and 9. So of course 4 is less than 9, so it's all good. So we increase j by 1. So what we would have is this. So j is 1 now, so x is not less than j, because 1 is smaller, right, than 4. So what we do here, we increase I by 1. So I would be in this position right now. So I is 7 and j is still in its own position, which is 1. Then we swap their positions, swap their values. So we would have 4, so 1 would come to the ith position, and 9 and 7 would come to the jth position. So this is our new value, right? So I is still there, x is still there, and j is now this one. So is x less than j? Of course. So we increase j by 1. So what do we have now? So j is now 3. So is x less than j? Of course. So we increase I by 1. So I is now this, and j is still in its own position, and then we try to swap their places. So what do we have after swapping? So it would be 4, 1, here would be 3, 7, 9, and 8. Right. So x is still in its position here, and I is now 3 and j is 9. Now we compare again. X is less than j, of course. Move on. J plus plus, so j would be 8 now. So j is 8 now. So we compare them again. So there's x is of course less than j, so we increase j. However, here in this case j has reached the limit of the array, right? So j is at the end, so we can't increase j. So what do we do here? We exchange x and I, you swap their places. So we would have 3, 1, and 4, 7, 9, and 8. So x is still there, and I is this one, and j is at the last position, right? Then we try to divide the whole array into two portions. So quicksort algorithm follows the divide and conquer theme. So we divide that into two portions. But you might be wondering, like, at what basis are we dividing the whole array? So this point is called the pivot. On the basis of this point, we are dividing the whole array into two portions. So this one is one array and this one is another one. Okay, so let's try to do it in a tree format so it's easier for you guys to understand. So this is another array, 7, 8, 9, and this is another array, so like the left side and the right side, right? And remember, the pivot is always a sorted value. So let's try to work on the left side first. So it's similar to before. We put x and I at the 0th position of the array, so this is the new array, and j is I plus 1, right? So remember what we did before, we compared both x and j. So here x is not less than j, right? So what did we do? We increase value of I. So here we have I and j in the same position, and then we used to swap their places, right? But as they are in the same position, swapping doesn't do anything, because you swap one with one, it's the same value, right? So we don't do anything here. So j has reached the end of the array, right? So what did we do before? We swapped the places of both x and I, right? So let's swap their places. So 1 would be here and 3 would be here, and this is still I, this is still j, this is your x. So remember, the ith position would be the pivot, so this is the pivot, and the pivot is always sorted. So we divided the array based on the pivot, right? So we divide this array too. So it would be 3 here and 1 here. So there's no point in putting x and I and j variables here, because there are one value, and we can't swap anything with anyone. So both of them are now a sorted value, a sorted portion of the main array. Then working on the right side, so similarly we would be taking x, I at the 0th position, j at the I plus 1 value. So we now compare again. So is x less than j? Yes, of course. So we increase j by 1. So 7, 9 and 8. So again we try to compare them. So is x less than j? Of course. We increase j by 1, but here j has reached the end of the array, right? So remember, we used to exchange swap the values of x and I. So as both of them are pointing to the same value, there's no point in swapping them. So 7 is now the pivot value. Based on that, we would be dividing this array into two portions. So let's do that. One would be 9 and one would be 8, another one is 7. So 7 is one value in an array, so this is already sorted, because we can't exchange I and j or x and I, so this is a sorted value. So let's start working on the right side of the array. So this is your x, this is your I, and this is your j. So is x less than j? No. So we increase I by 1. So I and j would be pointing to the same value, and x is still at 9. Right, so there's no point in swapping these values because they are pointing to the same thing. So j has reached the end of the array. Right. So now what we did before is we swap the places of x and I, right? So we swap the places. So this is still your x, this is your I and j. So 9 is the pivoting point. Right, so based on that we divide that into two portions. So one would be 8, one would be 9. So each of them, they are their own single value in an array, right? So it's a one length array, so they are sorted on their own. So both of them are sorted values, right? Let's now try to put all the things together. So initially we did all of this and we found the pivot 4, right? And then we found the pivot 3, 1. Similarly, we found 7, we found 9, right? So let's try to traverse the whole tree together. So initially, so if you remember the tree structure, how do we use to traverse values? So we put this value first, and this one, and this one, and we go back. This one, this one, this one, and this one. That's how we traverse this whole tree. Okay, so let's try to do that. So this is the whole tree, this is the main root, and these are the leaf nodes, right? So this is your first value, so let's write that down. So 1. This is your second value, so 3. This is your third value, which is 4. So we go to the right side and we see 7 here, so write 7. Then we go to the right side, which is 8. And then finally we have 9. So see, we have a complete sorted array. We came from this 47138 to 13478. So hope you guys did understand this whole algorithm. This is a bit complex from like what you are used to using, like bubble sort or selection sort, but this algorithm is still being used in cases, and you can look at the main algorithm from like different websites like Geek for Geeks and try to put that beside the video while you're studying. So this is kind of easy. Try to code this in like whatever language you prefer. So hope you guys liked it, and if you have any questions or suggestions, feel free to comment down below. Thank you.